Now that we're at the command line, let's start by pinging a storage array I've got in the lab. Its DNS name is psan sin01. It's short for Production Sandbatch Synology Array number 1. So we type ping space psan sin01 and hit return. And there we go. The first line we get back tells us that the IP address of our Synology SAN array is 192.168.0.7, and then the next 4 lines show us that we get 4 replies back from our 4 ICMP echo requests that we send out as part of the ping command. Each reply coming back to us in either 3 milliseconds or less, and that's round trip time. So there and back in either 3 milliseconds or less. That's pretty good performance. A trace route to psan sin01 shows us that the array, which does CIFS, NFS and iSCSI in the lab, is on the same layer 2 network as the host that we're running the ping and the trace route from. If it was on a different network segment, we'd see a hop across at least one router. And we'll see an example of what a hop looks like in just a moment. So let's make things a little more complicated. Let's ping and trace the route to a couple of hosts on the internet, as these will definitely involve a lot of network hops. Let's start out by pinging trainsignal.com. As we can see, we're instantly able to resolve trainsignal.com to an IP address of 184.106.104.28, and we can see again that of the 4 ICMP echo requests we send, we get 4 ICMP echo responses back. But this time, if we look closely, we see that the round trip time for each of these ICMP exchanges is around 122 milliseconds, and that's way more than when we pinged the local Synology storage array on our local network. So that's obvious. We hit the internet and response time or network latency soars. Now let's run a trace route against pluralsight.com. First hop on the journey is my home router. From there, we're out to the internet. We move through London, across the Channel to Paris, and then across the Atlantic to the US. The first hop in the US is Washington, then we hop over to Chicago, then to Denver, and then to Salt Lake City. Let's kill the trace route, as I think we've made the point of hopping around the internet. Now, what's the point of looking at this? Well, especially if you're tracing the route to an iSCSI target and you see a long and complex route, like the route that packets are taking from my machine to pluralsight.com, then you know you've got a problem. But even if all those hops are on your internal network, each and every one of those hops is a layer 3 network router, and routing iSCSI at layer 3 is not a great idea from performance, security, or a stability perspective. But what if it's CIFS or NFS? Well, the same kind of applies. The less hops the better, and the lower the latency of the round trip time, the better. Though of course, NAS traffic like CIFS and NFS is designed to be routed at layer 3, but you might be troubleshooting an NFS connectivity problem, and the trace route might show you that one of the hops is a firewall that's not actually configured to allow your connection through. So, using a trace route can be helpful in identifying things like firewalls that you have to pass through as you make the connection to the remote system. Now let's look at NSLookup. NSLookup, short for Name Server Lookup, is a DNS resolution tool. Let's take a look at it in action. To start out, we type nslookup on the command line. This puts us into an interactive session. We can see that the name server we're currently using is the local DNS server on my local network called skyrouter.home with an IP address of 192.168.0.1. Now let's see if it can resolve an internet host name like www.hds.com. Great! So my local DNS server is able to resolve the IP address of www.hds.com. But nslookup can be pointed at other name servers. So let's test a free public Google DNS server. We do this by telling nslookup to send all future queries to one of Google's public DNS servers with an easy to remember IP address of 8.8.8.8. Now then, let's see if Google's public DNS server can resolve the address of my website, nigelpoulton.com. And there we go. We get an IP address of 69.89.25.198. But within nslookup, we can also perform reverse lookups by putting in an IP address. Let's enter the IP address for the server that's hosting my website, 69.89.25.198. Interestingly, we don't get nigelpoulton.com back. Instead, we get a server at bluehost.com, and that's fine. All this means is that Bluehost is hosting my website along with a ton of other websites at an IP address of 69.89.25.198. Now, let's exit nslookup and take a quick look at the IP configuration of my local machine. We quit out of nslookup by typing the exit command, and then to check my local IP configuration, we type the ipconfig/all command at the command line. Quite a lot of information, fair enough, but three important things. First of all, we can see that this machine has an IP address of 192.168.0.10. We can also see that it's got a default gateway of 192.168.0.1, as well as a DNS server of 192.168.0.1. Now, if we didn't have a default gateway set, we wouldn't be able to get off our layer 2 network that we're on, meaning that if our host couldn't connect to the NAS, and we discovered that the default gateway was either not set or set incorrectly, putting that right might fix the issue. Or, if our system couldn't resolve an IP address from the name of a NAS resource or the IP address of a nice guzzy target from its name, and we discovered that our host either had no configured DNS servers or the wrong DNS servers configured, putting this right might fix that issue. Okay, time for one last slide covering off some other problems that you might encounter as a storage administrator.